Okay, this should be the last video that I'm recording about this topic, although it is missing of the matrix vector product. Um, I've implemented the call operator for both access and assignment in the compressed sparse row implementation. The access follows a simple structure that we see, like we know that, for example, if we want to access the third, if we see a matrix with these three vectors, the vectors of the values, the vector of the respective column indices, and the vector of the cumulative number of non-zero elements row by row, and yes, this is a little bit superfluous, if I can say so. And we know, for example, if we want to access the third element in position 3, 3, we know that there are 4 elements before the third row, before the fourth row, and 6 elements after, and 2 elements in row 3, which means 6 elements by the end of the matrix. And this means that we can access the matrix with a while loop that loops over the like we find the that our values go from the fourth position in values to the fifth position in values. That means 1, 2, 3, 4, 0, 1, 2, 3, 4, namely we can iterate over these two elements in search of a correspondence in the jth position. There is a correspondence in the jth position, which is the last, this one, and it corresponds to the value of 6. And after that, we should test this function on the main, but before that, it comes the hard part, if we can say so. That is the assignment operator. We have to return a reference to a position in our class. And first of all, we follow a similar pattern as the access operator, but we have to return a value .at, that means that returns a reference of the vector to position index edx of the vector values. And I've got some trouble when defining an iterator the vector, the standard vector of type t dot. I follow this by seeing at reference at c++.com. The problem with this thing is that the compilation doesn't really work because it says in member file it gives this message that I couldn't fully understand, but then I remember that that C++ can automatically infer the type we want by using the keyword auto, and that leads to no compilation error. Yes, and we can continue our code and insert the value at position index, that is the position where we exit the loop, and yes, it's the position where we exit the loop, and therefore it's where we want to insert the new value and the new column index. These I hope it works. I haven't tested yet. And and of course, before returning the new element at position index, we have to like and I noticed this mistake right now. I think we have to insert our column index j inside the column index vector, not a zero like value. And of course we have to increment the number of elements, the number of the number of non-zero elements by 1, and to do that we increment by 1 every number after the ith row, because when we add an element to row I, and this means that in row I plus 1, the total number of previous non-zero values increases by 1, and so do all subsequent values in the vector. Nice. Then we try to implement this thing on the main.c++. We create an object called Sparse Matrix, but CSR of doubles. The same the same size as the other ones, but this, and we try to fill the third matrix in the double for loop from a specified test matrix, which is the usual 0, 0, 3.1, 0, 4 that we've already seen. And it would be really nice if everything would work at the first time, but coding doesn't work like that. Even worse if I'm not a good programmer, as in fact I'm not a good programmer. I just try to code something for fun and for YouTubing a little bit because yes, it is fun, I think. And here we set our metrics. Then we have to print the metrics, and to do that uh, mm, no, no, we have to copy like this one. Element in position 1, 2. I standard cout try the no, compressed sparse row. I always forget, yes, the name. Try the CSR implementation. Then I add a new line and we should get like a 5 if I'm not wrong. Let's see if it does work. No. Something is has gone wrong. Undefined reference to sparse matrix operator const. What the hell? Ah, I know what. It's the fact that I've defined a pure virtual method in the sparse matrix. Therefore, if I inherit from a sparse matrix in the sparse CSR, I think I have to define this operator here, but by now we can just do something like that and comment this operator. I hope no one gets angry because of this. We try. Oh, sorry. Ah, okay. Yes, someone gets angry, and it's the sparse matrix CEO that gets angry. Mm, let's see. Then, oh yeah, of course. Redefinition of. No, I didn't mean to change this one. I wanted to change. Sorry. And now redefinition, or maybe I've redefined somewhere. Why is that element closing brace not found? No, sorry, I was wrong. Wrong file. Mm, what's the error again? Like sparse matrix COT, it's about COO redefinition. Mm, maybe it's the const keyword that I'm missing, but it's not operator const other const override standard vector v return v. That should work. Ah, but it's not okay like this. Doesn't work like that. Um, I think I'll pause for a short while. Okay, I simply I've forgotten some. I mean, I was confused between the two classes, and I modified something that I should have modified. And here we are. Now I've managed to compile the whole thing. Now let's see if the executable, although it's not a .exe, is um, Linux-like executable, because I'm working with a Windows subsystem for Linux. Wow, that works even better than I ever thought. I love this. Yes, I have to implement the dot product. No, not the dot product. It's a collection of dot products. It's a matrix vector product. And for today, it's enough. I don't think I realized any other videos in a long time, but for now is so far I'm satisfied with the result. Thank you for watching, and see you.